Hey guys, so today I am going to talk to you all about mixtures. So what are mixtures? So mixtures are basically when we use two or more distributions. They can be the same type of distribution or different types of distribution, but on the same range. So let's say we have this range, okay? And let's focus on just Poisson distributions for today. So we have, let's say, two Poisson distributions or three Poisson distributions. It doesn't matter how many we have, but all of these distributions will be assigned a weightage. So for example, if we look at two Poisson distributions, let's say Z is equal to Poisson with lambda equals 2 plus another Poisson with lambda equals 1. So both of these Poisson distributions need to be assigned a weightage because they are used on the same range. So let's, for example, say the first Poisson has a weightage of 0.6 and the second Poisson has a weightage of 0.4. So you can see that 0.6 plus 0.4 is equal to 1, and probability of the entire distribution has to be equal to 1, right? So the weightage will always be equal to 1. They will be broken down depending on how many distributions you have, but it will always equal 1. So what if we had to find the mean of this distribution? So in a Poisson distribution, we know that the mean is equal to lambda in general, right? But when we have a mixture distribution, we have to assign the weightage. So the mean of the whole distribution, which is Z, will be 0.6 into the mean of, let's call this X and this Y. So it will be into the mean of X plus 0.4 into the mean of Y. So since we know that in a Poisson distribution mean is lambda, here it will be 0.6. Here lambda is equal to 2 plus 0.4 into 1, which is 1.2 plus 0.4, which is equal to 1.6. So this will be the mean of the entire distribution. So what about variance? Variance is, when you find the variance for a mixture distribution, you cannot directly assign the weightage like we do in mean. We always have to find the second moment first. So what is the second moment in general of the Poisson distribution? So we know that variance is also equal to lambda and mean is equal to lambda, right? So then E of X squared will be the variance plus the mean squared. Where do we get this from? Because variance of X is equal to the second moment minus the first moment, which is the mean squared. So when you rearrange the equation, we get this. Okay? So when you write this in the form of Poisson, we have the second moment is equal to lambda plus lambda squared. Why? Because the variance in a Poisson distribution is equal to lambda. So if we try and find the second moment for the example that we're doing, we get, so the first distribution, the weightage is 0.6. So we have 0.6 into lambda is equal to 2. So 2 plus 2 squared plus 0.4 into 1 plus 1 squared. So when you calculate this, the final answer that you get is 4.4. So 4.4 will be the variance for your answer. When we calculate this, the final answer that we get is 4.4. So this now is used to calculate the variance. So the variance will be E of Z squared, which is 4.4, minus the mean we found is 1.6, minus 1.6 squared. When you calculate, you get 1.84. So this is how you find mean and variance for a mixture distribution. So what about probability of, say, if Poisson is a discrete distribution. So if we're trying to find the probability of, say, z equals 0, it's the same thing. We have to add the weightage in. So in this case, it'll be 0.6 into the probability of x equals 0 plus 0.4 into the probability of y equals 0. This part is calculated in the usual way that probability is calculated for a Poisson distribution. So we know that the PDF for Poisson is e to the power minus lambda to the power k divided by k factorial. So the probability is found, the individual probabilities are found in the usual way. The only difference is we have to add in the weightage in order to find the probability for the entire mixture distribution. So now let's look at a question on Excel so that we can learn a little more. Okay, so now let's look at an example on Excel. So this question says the claim count distribution can be expressed as a mixed Poisson distribution. The mean of the Poisson distribution is distributed as follows. So the mean of a Poisson distribution, as I said before, is lambda. So we have different lambda values and different probabilities. So these probabilities are the weightage. And if you can see here, the summation of this will always be equal to 1. So the question asks for the mean and the variance. So if we were to find the mean, we have to find the mean according to the different weightage. And then once we sum it up, we have the mean for the entire distribution. So we know the mean for a Poisson process is the lambda, and then we multiply by the weightage. So if we drag that down, we get the respective means for the different lambda values and the weightage. So the summation of all of this will be the mean for the entire mixture distribution. So for variance, we first have to find the second moment, which is e of x squared. So as we discussed earlier, it is the variance plus first moment squared, right? So we have the variance, which is lambda, plus the first moment, which is e of x. Sorry, not e of x, it's also lambda squared. And this we times with the probability. So if we do this for the entire question and we sum it up, we get the second moment. So we know that the variance is equal to second moment minus the first moment squared, which is 41.9395. So I've done the question here. So we get the mean 7.592 and variance 49.9395. The second part of the question asks for the probability of claims that are greater than 11. So now, since this is the discrete distribution, the probability of greater than 11 is equal to 1 minus the probability of less than or equal to 11. So how do we find the probability of, in like 1, 2, 3 or anything, of a mixture distribution? So we have to find the probability of 0, 1, 2 all the way to 11, right? So it's the same method that we found the mean and the variance. So if we say for the probability of 0, we have to find the probability of 0 when lambda is equal to 1, and we multiply it by the weightage. Since we're using Excel, we can use the Excel function. So x in this case would be probability of what? So in this case 0. And the mean we know is lambda. And we want the probability mass function, so we insert false. And we need this entire probability multiplied by the weightage. So if we do this for the entire distribution, the summation that we get here would be the probability of x equals 0 for this mixture distribution. okay, because it's multiplied by the weightage, and the summation would be the probability of 0. So if you do this for the entire up to 11, this is what we get. So the probability of x greater than or equal to 11 will be 1 minus the probability of x less than or equal to 11, which is 1 minus the summation of the probability from 0 up until 11. So all of these probabilities are, so this is the probability of x equals 6, which is where lambda equals to 1, and then we multiply by the weightage. And over here, if you look at it, it's when lambda equals 14, and we multiply by the weightage. So this value here will be the probability of x equals 6 for the entire mixture distribution. So 1 minus the summation of all of this would be 0.28002, which is the probability of x greater than 11 for this given mixture distribution. I hope you all understood, and if you have any questions, leave it in the comments. Thank you so much for watching.